Hello, and welcome to the Global Security Sales Organization's ASA Firewall Training Module. I'm John Kanicki, Consulting Systems Engineer with Cisco, and today I will be covering the ASA Proof of Value module. This ASA Proof of Value module is focused around ASA Firewall POV, ASA VPN, ASA NGFW, and NGIPS will be covered in separate modules. The intent of this module is not to teach you step by step how to execute a particular POV, as each POV is unique, but rather provide you guidance on how to best prepare and plan for your ASA Firewall POV. As we flow through today's agenda, we will cover determining the scope of a POV, differentiating features of ASA, deployment considerations, and management considerations. At the end of the module, you should be able to determine the scope of an ASA POV, identify differentiating features for a POV, determine equipment selection, hardware versus virtual appliances, describe basic deployment considerations and dependencies, and lastly, choose an appropriate management platform for your POV. The purpose of a POV is to tie features, functionality, and capabilities of a Cisco solution directly to a customer need or desired business outcome. Therefore, the most important thing which happens in a POV is having an effective discussion related to the desired outcomes and mapping those desired outcomes to functionality which will be demonstrated during the POV. Once we have mapped the customer goals to ASA functionality, you should determine the minimum features and functions required to meet these objectives. It may be nice to showcase the entire boatload of features and functionality an ASA can provide, but that is better accomplished with demos and discussions outside the POV. The more straightforward and simple the POV is, the clearer its success will be. A key step in scoping a POV is to agree on specific testing and success criteria. This is critical, and all efforts should be taken not to deviate from this in what is known as POV scope creep. If the customer gets excited about our solution and wants to see more and more and more, keep them on track with the agreed upon plan and success criteria. But don't hamper their enthusiasm. Instead, suggest that after all the success criteria is met and success is agreed upon, there may be time for additional testing. Keep on track to succeed. Succeeding brings up a very important point. Get the stakeholders to verbally acknowledge success. Even better if you can get it in writing as well. This has a very powerful psychological effect of both commitment and closure. Lastly, document everything when possible. Having the success documented is useful to the customer for selling their Cisco decision internally and to the Cisco sales team for positioning our superiority with stakeholders who were not directly involved in the POV. Whenever possible, we should try to use ASA specific or differentiating features when meeting the customer goals outlined in the POV. This can sometimes be easier said than done. Much functionality is common among all firewall offerings today, or in some cases the customer requirements are so basic or foundational that differentiation can be a challenge. In these difficult situations, show the basics needed to meet the success criteria as outlined in the POV, and sell the customer on Cisco architectures, strategy, and our broad range of solutions. If they want to see any of this other stuff, use a demo and not the POV. That said, wherever it is possible, use ASA differentiating features such as the partial list shown here. Certain features such as TrustSec and NetFlow are simple on the surface, but provide strong differentiation and tie in clearly with Cisco architectures and solutions which competitors can't hold a candle to, such as network as a sensor, network as an enforcer, and integrated threat defense. Even in situations where the firewall functionality requirements are very basic, the network integration, availability, and scalability features of ASA are unmatched in the industry. This can make a huge difference when all that is needed is basic firewall. Integration flexibility, maximum availability, and scalability are foundational considerations of all technology deployments. Consider making these focal points for POV success. Although this training module is focused on the ASA traditional firewall functionality, don't forget ASA also contains class-leading next-gen IPS, AMP, next-gen firewall, cloud web security, and the world's best VPN solution. So if the customer's POV requirements span both traditional firewall functionality and next-generation types of services, ASA can differentiate itself across the board. The key is to help the customer develop an understanding of these differentiators and then make them requirements of the POV, thus blocking competitors completely or limiting their success. One of the major decisions we need to make in planning a POV is which equipment to use. When it comes to executing a POV, a virtual appliance is always the best way to lead if it won't put us at a competitive disadvantage. If a customer is particularly interested in POV of ASAV, this is a no-brainer, test with ASAV. But if they are testing ASA functionality with no significant performance or network integration requirements, you can also complete an ASA POV with ASAV even if the targeted platform for purchase is an ASA physical appliance. Obviously, it's quicker and easier to get approved, cheaper for Cisco, and you won't have the demo police coming after you for overdue gear if you use an ASAV. With that said, in many cases, you will need to use appropriately sized ASA hardware. A few things which will drive you in selecting hardware. The first is performance. If it's in excess of 2 gig, ASAV is out. There are also a few features not supported in ASAV that are supported in the ASA hardware appliances. As of ASA release 9.5, these features include clustering, multi-context, active-active failover, and Ether channel. You also cannot run integrated source fire services within an ASAV, but you could run a separate virtual sensor if that makes sense for your use case. In general, most capabilities of ASA are supported in ASAV, but at lower scalability numbers. Another factor which sometimes comes into play in the decision is a customer who requires the POV to be completed on the models that they will be purchasing. If this is an absolute must from the customer's perspective, that decision is pretty simple. Use the platform they desire as it is a requirement of the POV. As we discuss ASA deployment considerations, please keep in mind that this section is by no means expected to be an ASA design or deployment all-inclusive training module. Here we just want to point out some key things to keep in mind as you are planning your POV. These are points of consideration mainly regarding feature compatibility, which if considered up front can help avoid pitfalls during the POV. I would highly recommend reviewing the ASA configuration guides on Cisco.com, as well as other sources listed at the end of this module for details regarding all of this. One of the first decision points will be which mode the ASA will be deployed in: routed, transparent, or if in multi-context, mixed mode. Mixed mode was introduced in ASA Services Module 8.5 and ASA 9.0.1. Mixed mode is simply running transparent firewall in one context and routed mode in another context. Routed mode is pretty easy to understand. Basically, the ASA is acting as a layer 3 boundary routing between interfaces. This is the most well understood firewall mode and has almost no mode-specific caveats. When the POV requires a transparent firewall deployment, in which the firewall acts as a bump in the wire, similar to a traditional IPS deployment, the ASA is not a layer 3 gateway. It is forwarding between interfaces at layer 2. This creates some specific feature dependencies which should be accounted for at the onset of the POV. One of the first considerations with transparent mode is that the ASA uses bridge groups for interface grouping. Each bridge group should have a management IP address configured on the IP subnet which the bridge group services. As of ASA 9.5, you can specify up to 250 bridge groups with 4 interfaces per group. Another important thing to know about transparent mode is that it will drop CDP traffic. But on the upside, you can use ether-type rules to allow non-IP traffic such as AppleTalk, IPX, MPLS, and BPDUs to pass through a transparent firewall. In transparent mode, the ASA does MAC lookups for forwarding decisions rather than route lookups. This can cause issues with certain traffic types or under certain conditions. These are few, and we won't go into the details here as it's beyond the scope of this discussion, but suffice it to know you need to review the configuration guide caveats around traffic handling and forwarding before considering using transparent mode for your POV. There are also several features not supported in transparent mode. This is very good to know when deciding which mode to deploy the firewall in. Probably the biggest ones are dynamic and multicast routing, QoS, and VPN termination. Regarding VPN in transparent mode, as of the current releases, the ASA can terminate site-to-site tunnels for ASA management only. No VPN methods are supported for traffic intended to pass through the ASA. Another major consideration which will need to be accounted for prior to a POV are HA and scalability deployment requirements. The simplest POVs will not require any HA or scalability configuration, but in many cases this is either required by the customer test cases or may even be the main purpose of the POV. Again, keep in mind this is not an all-inclusive design module. We just want to point out things you need to know when planning a POV to help you choose the best methods based on your requirements. When it comes to pure high availability, we have 2 modes to consider: active standby and active-active. A third technique, clustering, provides both scalability and availability. Active standby is generally my go-to method whenever customers require HA but have no particular scalability or multi-context requirements. Active standby is simple, easy to configure and troubleshoot, and in keeping with the KISS theory, keeps the POV simple while providing HA. Active-active is really a misnomer in my opinion. Active-active HA on the ASA is really multi-context firewall in which each context is running active standby, and then load sharing by alternating which ASA of the pair is active and which is standby for each context or virtual firewall. Active-active makes sense when the customer POV already requires multi-context mode. It should also be noted that with an active-active design, each ASA must still be able to handle the entire load in the event of a failure because all traffic will be on one ASA. Where customers need HA and scalability, use clustering. In clustering, the cluster of ASAs forwards traffic for all contexts, and it provides high availability while sharing load across all the ASAs in the cluster. The last major deployment consideration we are going to discuss today is multi-context. This is a methodology which allows customers to break a single ASA into multiple virtual firewalls. This provides policy as well as administrative separation and can allow a single ASA appliance to appear as a number of different firewalls for different applications. This is a good option for customers who want to use fewer larger firewalls but still maintain separation of policies and administration based on use case. Each context can have its own policy, administrators, interfaces, and resources defined. Multi-context mode would be applicable in a POV where customers wish to consolidate hardware while maintaining policy separation, or provide administrative capabilities to specific users to firewalls under their control while using a single hardware appliance. Please take note of the unsupported features in multi-context mode listed here. When going into a POV, you will need to decide which method of management to use. Beyond CLI, there are currently two options. ASDM, which is functionally a single device management application, and Cisco Security Manager, which is an enterprise-class multi-device manager. ASDM is the go-to method for POVs where customers are not overly concerned with enterprise-class management features and are more focused on ASA functionality. In these cases, ASDM is simple and easy to use. ASDM does not require you to install any additional software or hardware or provision of VM, but it has a number of disadvantages. No shared policies, shared objects, and only a single device can be configured or troubleshot at any particular time. CSM solves all those shortcomings, but adds complexity in that you must install a server and software. Generally, you would lead with CSM in your POV when the customer desires to evaluate enterprise class management along with ASA features. In the near future, when ASA management is available in the Firesite Defense Center, you will also have the option of leading with it in POVs, which require enterprise class management. If you want more details about anything that was discussed in today's training, please refer to these additional resources as well as the configuration guides on Cisco.com. Now that you're at the end of this training module, you should be able to determine the scope of an ASA POV, identify differentiating features, determine equipment selection regarding hardware versus virtual appliances, describe basic deployment considerations and dependencies, and choose an appropriate management platform for your POV. Thank you.